Today we're going to be looking at converting between exponential and radical form, so converting between roots and exponents or indices. So the main thing that I need everyone to remember today is that if you have some base, be it a variable or a constant, and you want to raise it to a fractional power, so that means that we have an indice or an exponent that has some term over another term as a fraction. This can actually be converted into radical form or root form. And so this would be, and we would write our root, and so the constant or the variable x would go underneath our root. Now our a becomes our power underneath that root. So that would be x to the a power, and then the b would be the root. And so as an example here, let's put this into concrete terms. So let's keep the x, but let's go 2 over 3. So x to the 2/3 power is the same thing as putting that x underneath a root symbol, raising it to the second power, and then making it a cube root or a third root. We're going to go through a lot of examples today. So we're going to go through some different concepts, but I'll show you as we go through problems. This is a lot better than just going through theory and then applying to problems later. We really want to be working through problems for this. So write 1 over root 5 in exponential form. So remember that we have our little formula. So we go x to the a over b is equal to x under the root to the power of a and the root b. So in this case, whenever we have a root that doesn't have a number, it means a square root. So that's a 2. So effectively that b would have to be a 2. Now the 5 is not raised to a power in the question, so that would be the first power. So we could rewrite this as 1 over 5 to the 1/2 power. And so whenever you see that, you can assume that just a normal square root is just going to be to the half power. And so interchanging and going back and forth between those can be helpful when we're doing some operations with surds and just different things in algebra and calculus later. The other thing that I notice is I can also change this if I wanted to. You might also see this as 5 to the negative 1/2 power. And so I prefer 1 over 5 to the half power when I'm presenting a final answer, but if I'm still operating with indices, I will probably keep this negative 1/2 and keep it in the numerator. Now the reason that this works is because remember that when we have a power in a denominator, we can flip it and make it negative or flip the sign on it if we come back up. So go back to one of our other videos on index laws if you're not familiar with that. So this one will be focusing more on going back and forth between radicals and roots and exponents. And so either of these final answers are perfectly okay. So this one looks a little bit trickier. So 1 over the cube root of 3 to the power of 2 is the way that we say that. And so we would just look at rewriting this in terms of our a and b, our fractional form. And so I could write 1 over, and then 3 would still be the base. The power would be our top or our numerator, and our root number would be our b or our bottom number, our denominator. And so we could write this as 1 over 3 to the power of 2/3. That means the same thing. We can also write this as 3 to the power of negative 2/3. So either of those options are okay. I would prefer to present them with not a negative exponent, so I would prefer the first. Write 6 to the power of 3 underneath the 6th root, or the 6th root of 6 to the power of 3. And so here we would then, maybe I'll start by rewriting it. And so we could say this is the same thing as 6. Now the root would be on the bottom and the power would be on top. Now something we can do here is just like a normal fraction, if we can simplify this, we're completely able to. So we can still do things like that. So 3 over 6 we could simplify into 1/2. So this will also be able to be represented as 6 to the power of 1/2. write 1 over the square root of x to the 5th power. So these should be starting to get familiar for you now. So we could rewrite this x. Now we've got a square root and then a 5th power on that x. Now this can be rewritten as 1 over x to the 5 halves. And so as I said before, we could put this into x to the negative 5 half, but I prefer it with a positive exponent, and so this would be the way that I kept that presented. So now the cube root of z to the 5th power, and so we should be pretty comfortable here. And so ultimately what this would equal would be z. Now we've got the 5th power, so that'll go in the numerator, and we're doing the cube root. And so this would be z to the power of 5 over 3. So now we're going to be moving backwards. So we're going to be going from exponential form into a radical form, or making it a radical expression. So here we've got 5 to the power of 2/3. So we've got a fractional power, which is a dead giveaway that we have the ability to convert this into some kind of root. And so 5 to the power of 2 over 3. We could rewrite this. Remember, our denominator will be our root value. So this would be a cube root. Then we would still have the same base of 5, and it would be to the numerator. So this would be squared. So the cube root of 5 squared. If we really wanted to do some operations there, we could also do that. We could then do 5 squared rather than presenting it like that. But we'll get into that in the next section. So right now, all we're doing is converting back and forth between radical and exponent. So now we want to write 11 to the negative 3/2 power as a radical. So the first thing I notice is that it's a negative fraction. And so I really, before I start manipulating this with roots, I really want to be looking at, can I make this into a positive power? And so hopefully from your index laws, you realize that a negative exponent means that we can flip it, we can get the reciprocal, and that will be a positive exponent. So this could be really written as 1 over 11 to the power of 3/2. Now, this is an easier place for me to start to make this into some kind of root. So 11 to 3/2, remember that's a square root, so the 2 being in the denominator, and then we've got a 3 in the numerator, which indicates that it's 11 to the power of 3. And so we could write 1 over, and now converting this to 11 cubed, and we don't need to write 2 next to the root. It's implied when it's a square. So that would be how we represent that. We don't really want to represent it with negatives. It's always better to represent it with positive exponents. Write 4 to the power of negative 2.5 as a radical. So this one can stump a lot of people, but really 2.5, could that also be represented as a fraction? And so I would rewrite 4 to the power of negative 2.5 as, if I've got a 2.5, I know that I'm really operating in halves. And so 2.5 is 5 halves, right? So 5 times 1/2 would then be 2.5, or half of 5 would be 2.5, whatever way that you remember it. And so I could rewrite this as 4 to the power of negative 5/2. From there, I would then want to flip it into the denominator so that it would become a positive exponent. And so we'd get 1 over 4 to the 5/2 power. And then finally converting that into a radical. So looking at going 1 over, and then it's the square root of 4 to the power of 5. And so we obviously could then go and solve that, but I'm not going to here. But this should be the kind of workflow that you're looking at. Write x to the power of 3/5 as a radical. So this one is nice and simple. It does involve a variable, but it's no different. So remember, the denominator is the root, so that's the 5th root. And we still have x as the base, and it's cubed, so to the 3rd power. And so that's how we would represent that as a radical. Write p to the power of negative 5/3 as a radical. Same process again. So we've got a negative exponent, so we want to convert this into a positive. And so p to the power of negative 5/3 could also be written as 1 over p to the 5/3. At this point, we're now ready to put this into radical form or root form. And so we can go 1 over and then p. That is the base. It is raised to the 5th power, and it is cube rooted. So maybe I'll make that a little bit neater. So 1 over the cube root of p to the 5th. So that brings us to the end of our video on converting between roots or radicals and exponents. Hopefully this gives you a good foundational understanding. It doesn't get too much harder than this. Honestly, you'll be using this a lot when you're evaluating and simplifying radicals and even index laws. And so it's a really, really fundamental skill to have, especially moving into year 11 methods, where you'll be using these kind of skills all the time, and it makes up the basis of Unit 1.